All right, moving on to question number 2. So now we're talking about integrals. So the question reads, how do you integrate sine 2x dx? Okay. So let's just write this down here. So let's say we have the integral of sine 2x in terms of dx, right? So let's say that u equals 2x. So we can see here again, we have a function within a function again. So we want to simplify this function and be able to derive it in a more simpler way and then sub back in our values. So let's say that u equals 2x, right? Let's derive du of dx, okay? So du of dx would equal 2, okay? So then let's say that we can treat these as different variables. So let's isolate for du. So du would equal 2 times dx. So we're going to sub in, and we're going to isolate for dx too. So isolate for dx, which is du over 2. Okay, so we're going to use 1 and 2, and we're going to sub this into our integral. Okay, so sub 1 and 2 into integral. If we sub 1 and 2 into the integral, we get the integral of sine of u and du over 2. We can take out this 1 over 2 constant within the integral to get sine of u du. And now we have transformed our integral in terms of x to integral in terms of u. And now we can simply do this integral because we know what the integral of sine is. And the integral of sine is negative cos. So it's going to be negative cos u plus c. Okay. And then we're just going to sub back in our u here, which is 2x, to get 1 over 2 negative cos 2x plus c. So this is the answer to integrating sine of 2x in terms of x. And we use a substitution method to simplify our integral. And by simplifying it, we're able to find integral easily. And then we just sub back in our u. And then this is what we got. And c is a constant. So whenever you're integrating, you always have to include a constant because you have to assume that there might be a constant when you're integrating. So the junior tutor did the same solution. They used substitution to simplify the integral. And by using substitution, they were able to find it. And then they substituted back u, and they solved. And they found our integral. Cool. All right. Let's move along to question number